Good evening, my name is Andrea, and today I'm going to be giving a virtual lab report on the simple pendulum that I did in fedcolorado.com. Specifically, my study will focus on the effects of different factors towards the period of small angle oscillations. If I elaborate, I have 3 research goals in total. The first one being the effects of length towards the period. The second one is the effect of different load and different masses towards the period. And finally, the effect of different gravitational fields towards the period. And for those of you who don't know what a simple pendulum is, it's essentially a mass suspended from a string that is moving from one pivot point, as shown in the GIF on the right. So the only formula you need to know for this experiment is t, or period, is equal to 2 pi over omega, where omega is equal to the root of gravity over length. Remember that this is only for small angle oscillations. This means that if you put the angle in cos theta, then you will get a similar answer to 1. For references, my angle is 30 degrees and cos 30 degrees is 0.86, which is similar to 1. The first experiment I did is investigating the effects of length of pendulum towards the period of pendulum. As you can see, the increase in length will also bring an increase in the period. Why is this so? I have an analogy. So if you were walking in a small circle, whereas your friend was walking in a big circle, your friend will finish later than you. Why? This is because your friend has more length to cover than you. Now, if we take a look at the formula as to explain our data, we can see that length is a numerator. When a numerator increases, so will the product. In our case, the product is the period. So moving on to the next experiment, the effect of mass towards the period. As we can see, no matter what change we do to the mass, there will be no change in the period. So why is this so? So if we take a look at this ride that we can find in amusement parks, no matter how little or many people are on that ride, how many mass is on that pendulum, there will be no change in the speed, right? So if we take a look at the formula, we can see that there is no mass in the formula of period at all. So it makes sense why there is no change. Finally, the last experiment is the effect of gravitational field towards the period. The increase in gravitational field brings a decrease in the period. Why is this so? The analogy is gravity is a magnet pulling an object. The stronger the gravity, or the stronger the magnet, the faster the object moves. If we look at the formula, we can see that gravity is a denominator. The bigger the denominator, the smaller the product, which is the period. So in conclusion, length is proportional to the period, gravity is inversely proportional, and mass has no effect at all. Thank you for listening.